So this is the first video on the chapter 4 review. The chapter 4 is on chemical foundations. And so you're learning about elements, atoms and ions in that chapter. And so we will go over question 1 first. What are the symbols and names of the 4 most abundant elements found in the human body? And these are carbon. So it's asking for symbol and name. So carbon is symbol C. Oxygen, symbol O. Hydrogen, symbol H. And then nitrogen, symbol N. So symbols refers to those symbols you find in the periodic table. That's a version of the periodic table here. And you see them, let me emphasize where they are. Carbon, nitrogen, oxygen are here. And then you have hydrogen here on the left side. It's an exception, hydrogen, for being here on the left side. You will learn that. So these are the main, elements that we are made of. All of us are made of those elements. And the study of, living matter, because we are living matter, is called organic chemistry. And organic chemistry really comes from, is the chemistry of carbon, because every living organism has carbon as the backbone for all their molecules. Then a lot of oxygen, hydrogen, and then nitrogen, mostly in, amino acids or proteins. Okay, so that answered the question 1. What are the 3 subatomic particles? Subatomic particles. So for this, it means you have to have learned about the atom. The atom is the building block of matter, and you can imagine it as a spherical thing. And atoms have what we call subatomic particles inside. So they are not like the first atomic theory of Dalton was saying, indivisible. They are not like that. They are actually made of parts that are smaller than the atom themselves. And so these are called the subatomic particles. So there is the proton, the neutron, and the electron. The protons are located in the nucleus. So you can imagine the atoms as a bit large sphere. And inside that large sphere in the center, you can see a little dot. And that's the nucleus. It's a tiny, tiny, tiny center compared to the size of the atom. You really have to visualize this as extremely small compared to the size of the atom. So the location of the protons and the neutrons is inside the nucleus. They are forming that very dense center of the atom. The electrons, they are outside of the nucleus. So as soon as you are out of the nucleus, they can be roaming around in that empty space. So the atoms are made of empty space, mostly. And all that big space where, around the nucleus is empty space. And that's where you find the electrons. And they are constantly moving around in that space. So that's why we also say that atoms are mostly empty space. So, and so that tiny center of the atom, the nucleus, that's where all the mass is, because the protons are about, I will put about, no, not this, about 1 atomic mass unit. So AMU is a unit, atomic mass unit. It's when you are referring to, an atom, it's a unit at that size, if you will, at the level of the atom, to visualize things more easily. And so both the neutrons and the protons are particles with both a very similar mass, very close to 1 atomic mass unit, but not exactly the same. They are slightly different, but very close to 1 atomic mass unit, both of them. The electron in comparison is, and again, I should put almost, has a mass of almost 0 atomic mass unit compared to the proton and the neutron, because its mass, the mass of an electron, is 2000 times smaller than the mass of one proton or the mass of one neutron. So it's negligible. They really do not contribute to the mass of atoms, electrons. Charge, and here we are talking about electrical charge. The charge of proton is +1. Neutrons, like the name suggested, are neutral, so no charge, no charge. This is important here. And the electrons are -1. They have a charge of -1. So here, those signs are important there. So to remember which one is which, here, protons are positive, right? Neutrons are neutral, no charge. And then electrons are -1. Here, it's not, you know, really proton and neutrons are easier to remember, and then the other one must be -1. So the symbols are typically P plus, but not P capital, it's lowercase p. P. And the plus, you will learn about ions in this chapter, and the charge, when we want to show a charge on an ion, we put it in the upper right corner of the symbol. So here the electron is with the -1 charge in the upper right corner. So you use the superscript here in the upper right. And then neutron, because they are neutrons are neutral, so their charge is 0. You can have it like this. So that's one of the symbols that you can use for neutrons, protons, and electrons. So all of this you have to learn by heart. This is something you need to know and remember. Okay. Okay. Let's go over question 3. What are the 7 elements that are diatomic molecules? So elements are made of one kind of atom. So one kind of symbol. If you look at the periodic table, this is called the periodic table of the elements. So they are all listed there, and there is no other elements than these that are listed there. So about 118, if you look at the numbers. And so each element has a symbol, but it happens that few elements are showing up in nature as diatomic molecules, which means, so a molecule is made of atoms bonded together. Diatomic means it's 2 atoms, but it's 2 atoms of the same kind. So D for 2, atomic for atoms, so 2 atoms of the same kind. So these elements, even though they are elements because they are made of only one kind of atom, we call them diatomic molecules because they are made of 2 atoms of the same kind. And they are. So there is the rule of 7, the rule of 7 to remember them, the rule of 7. So let's go over the rule of 7. You start with atomic number 7, and that's here nitrogen. Atomic number 7. If you look at the key, above the symbol, it's the atomic number. So the number above the N, capital N, is 7, and that's the atomic number. So you start at atomic number 7, and you go until the group 7, group 7A here. And then to make the figure 7, you go down the column of, you go down and you are going over chlorine, bromine, iodine. So that's a 7. And then the 7th one, because that's only 6 actually, right? You can see that there's only 6 there. The 7th one is hydrogen here, right? Hydrogen. So that's how we remember all the diatomic molecules that are elements. So, and we call them the same way that they are when you are talking just about a single atom of nitrogen or oxygen, fluorine, etc. When we are referring to the element that you find in nature, so the nitrogen in the air, the oxygen in the air, the fluorine gas, the chlorine gas, the bromine liquid, or the iodine crystals, or the hydrogen gas, we call them the same way. And so they are. We started with, sorry, nitrogen. So nitrogen, N2, oxygen, O2. So let me, here, the 2 as a subscript. We call that a subscript when it's in the lower right corner. The subscript here means you have 2 nitrogen atoms bonded together. And that's how the nitrogen gas is. The nitrogen you're breathing, you know, in the air is made of 2 nitrogen atoms bonded together. Fluorine, F2, chlorine, Cl2, bromine, yeah, bromine, Br2, Br. So symbols of elements, notice here how they are always made with a capital letter and sometimes only that, one capital letter, like hydrogen, boron, carbon, nitrogen, oxygen, fluorine are all made of a single capital letter. And because there's not enough letters in the alphabet, then there is a second letter for most of the other symbols. The second letter is always a lowercase. So you have to write your symbols correctly, because if you don't, for example, look at cobalt here. If you write cobalt as capital C, capital O, you could mean actually carbon and oxygen together. So cobalt is capital C and lowercase o. It is important you write them properly. So let me put those 2s as subscript. These are subscript, meaning you have 2 atoms of bromine here. I have 6, and then the hydrogen, H2, also a gas. They are not all a gas, right? Nitrogen, oxygen, fluorine, chlorine, and hydrogen are a gas. Oh, I'm missing iodine. Iodine, I2. So they are all gases except bromine is a brown liquid with a stench. And iodine is a purple, dark purple crystal solid. So these are the 7 diatomic elements, and it is important to remember them as well.